All right, let's do some practice. We're going to start by looking at this one. A vehicle purchased for $29,800 depreciates at a constant rate. Okay. A rate of 6%. It's going to be exponential. If it were decreasing by $600 every year, that'd be linear. But by a percent every year, that's going to be exponential. Determine the approximate value of the vehicle 13 years after purchase. We're going to need a function, and then we have to use the function. Okay. If we can get a function to model it, we can plug in 13 and find out. So we know here that y is equal to 1 plus r to the x, or you could use b to the x with an a in front. A is the starting value. What's our starting value here? $29,800. As a side note, car depreciation doesn't usually work like this unless you're already buying a used car. If you buy a new car, the depreciation is like, just like falls down a cliff, and then it's like exponential after that. As soon as you drive a new car home, the value is much smaller, but that's fine. Anyway, it's decreasing by 6% every year. So what's our R value? It's going to be negative 6%, negative 0.06. All right, and X is going to be number of years. So Y is the value in dollars. X is number of years we've had it. So if we simplify this, we get 29,800 times, this becomes 0.94 to the X. Decreasing by 6% means we're multiplying by 94%. All right, checks out. And we want to know after 13 years. Just as another reminder, whenever you're working on these homework problems, write things down on paper. Don't try to just do it all on a computer. It's not going to work very well. Write things down on paper. The y will be 29,800 times 0.94 raised to the 13th power. And now we'll have to use a calculator here. 29,800 times 0.94 raised to the 13th power. 13,331.4799. I don't remember how many decimal places it wanted. Let's check. Round to the nearest whole dollar. So that's about $13,331. We're going to round down because this is a 4. 13,331. Let's see if it likes it. It already has the dollar sign there. That's good. Hey, we got it. Next up, I want to look at number 4. Are these linear, exponential, or neither? Remember, linear is like adding or subtracting the same amount every time. Exponential is multiplying or dividing by the same every time. On this first one, we lost 9. Well, we didn't lose 9 again, so it's not linear. We did lose 10%, maybe? We lost 10%. What happens if we lose 10% of this? That's 8.1. We lose 8.1. Oh, yeah, that is that. Yeah, this first one is exponential. Here, what's happening? We lost 10, and then we lost 10 again, and we lost 10 again. Okay. That's linear. We're losing a constant amount. We're adding or subtracting the same number every time. Here, we lost 29. Okay, it's not linear. We're not losing the same amount. What percent did we lose? We lost 19. 19 is what percent of 80? 19 is what percent of 80? So 19 over 80 is the answer. All right, we lost 23.75%. Did we lose that same amount from 61? Did we lose about 14.5 about? No, we lost more than that. Not going to be exponential. We're not losing a constant percent every time. This last one's kind of hard to see. but that's the idea here. Exponential, we're losing the same percent or gaining the same percent. Linear, we're adding or subtracting the same number every time. All right, let's look at number 10. This one's a little bit more complicated, so I wanted to give you guys, I usually find the complicated ones and make sure to include them in this video. A house was valued at 110 grand in the year 1995. Let's start writing stuff down. And in the year 2023, it was worth $1 million. Probably, if this question were updated. It appreciated by 160K in 2008. Ooh, 2008. Yeah, that's another interesting story for housing prices. So 160,000, 2008. What was the annual growth rate between those years? Ooh, that's interesting. It's asking us to find the growth rate. We need the equation. We know the starting value. We just don't know the B. And specifically here, we don't know the R. So this is like the problem that we did in the notes. Okay. Y is A times B to the X. And we know our starting value is 110,000. I'm going to write it as 110. Let X equal the number of years after 1995. And Y equal the value in thousands of dollars. That way we just don't have to write as many zeros everywhere. So how can we write this information as a point? How many years after 1995 are we? That's our X. It's 13 years later. What's the value in thousands of dollars? That's our Y. $160,000. Let's find our B. The Y is 160. And X is 13. To solve for B, we need to divide both sides by 110. When we get that, we get 16 over 11 is equal to B to the 13th power. Now we can take the 13th root of both sides. And remember, that's the same as raising 16 over 11, the exponent of 1 over 13. We can use a calculator for this. 16 over 11 raised to the 1/13th power, 1.02924. I'm choosing this many decimal places because I want to have at least 4 decimal places for our R value. Because remember, what's the difference between our two forms? B is just 1 plus R. So what's R here? 0.02924. So it's growing by about 3%, right? 2.924% every year. That's our R value. R is equal to, and it says round it to 4 decimal places. Oh, I have 4 significant figures. 4 decimal places, it'll be 0, 2, 9, 2 is 4 decimal places. 4 significant figures is usually best. But let's follow the instructions. 0.292. How do you write that in percentage form? Well, that's 2.92%, about 3%. If it grows by the same percentage, which it didn't, between 2008 and 2010, I don't think it gained value. Big housing crash then. What will the value equal in 2012? Well, we just take our function and answer the question. So we know that Y is equal to A, which is 110, times B, which is about 1.02924. Well, it wanted us to round the 2 raised to the X. And 2012, how many years after 1995 is that? 17, I think. Yeah. X equals 17. And it wants us to round to the nearest $1,000. Let's use a calculator. 110 times 1.0242 raised to the 17, about $165,000. So $165,000 is our answer. Oh. Uh-oh, what did I do? Do we have the right growth rate? 2.292. Oh, we didn't type it in right. About $179,000. Woo. All right, let me know if you have any questions. I hope this video helped you guys, and have a great time with more exponential functions. Bye bye.